Hi guys, welcome back to Chem Talks. Last episode we learned how to write the electron configuration for elements. We learned that we don't have to memorize what order the orbitals fills because we can read the periodic table, and once we know how to read the periodic table, it prevents us from having to memorize them. We do have to remember two things though, that the d orbitals, the principal quantum number is always one behind whatever row it's in, and then the f orbitals are always 2 rows behind, so don't forget that. Now there are exceptions to the rules we learned last time. There's some elements that don't quite fill that, but we're not going to worry about that. When you get up at AP Chem, you may get into that, but for us, we're going to just assume that every element fills as we learned. Now the problem though that with last time we only learned 2 of the 4 quantum numbers. We only saw 2 of the 4. We saw the principal, which is the main energy level, how far away from the nucleus, and then we saw the orbital, okay, quantum number. But we didn't find out our magnetic or our spin. In this episode we're going to learn how we represent those, and that's done through something called electron notation. So let's go ahead and get started. Maybe. Okay. Electron notations is simply a visual representation of the 4 quantum numbers. Basically, it's a picture. We're going to draw a picture representing the 4 quantum numbers. Sometimes you'll hear it called orbital notations. Okay, remember the 4 principal quantum numbers, or the 4 quantum numbers, the principal quantum number, that's our energy level, how far away from the nucleus, corresponds to the row. The orbital quantum number, which is your sublevel shape, S, P, D, or F. The magnetic quantum number, which refers to, for P, D, and F, which angle the axis it's on. That's going to come into play this episode. And then finally our spin quantum number. That's which way the direction of the electron is spinning, clockwise or counterclockwise. In electron configuration we did principal and orbital. Now with electron notations we're going to be able to add magnetic and spin to those. Okay, so what we're going to do for our sake of our class is we're going to use circles to represent each orbital. So we're drawing a picture, we're going to be drawing circles. Everybody can do this. The other thing, so here it is. S has 1 position, so it's going to have 1 circle. P has 3, 1, 2, 3. And then D, how many should D have? Well, hopefully you're saying 5, and it should have 5. And F should have 7 circles. The other part you got to be able to draw are slashes. Okay, slashes represents the electrons. So in this example right here, this orbital would have 2 electrons, one spinning clockwise, one spinning counterclockwise. So pretty simple. Here's what you need to note though. Most notations done outside the class uses boxes instead of circles and arrows instead of slashes. It looks something like this. So why don't we do it? Well, simply circles and slashes are a lot easier for you guys to draw, a lot quicker to draw. So while we're using circles and slashes, most places will show it as boxes with arrows being up and down. So they mean the same thing, we just do it slightly different to make life a little bit easier for you. Okay, we need to talk about the rules governing electron notations and configuration. Some of them you already know, you've been doing already. There's a couple new ones, but the ones you have been, we're just going to assign names to you. You do need to know all 4 of these rules and be able to identify them. The first one is what we call the Aufbau principle. An Aufbau principle says electrons enter orbitals of the lowest energy first. What's that mean? Well, it means when we start writing out electron configuration, we always start at the bottom with hydrogen. Okay, so electrons fill up the least energy, the lowest energy first before moving on to the next higher level. You've been doing this already, nothing new, we're just giving a name, the Aufbau principle. So they fill up the S's, then the P's, and the D's, and the F's. Okay, so they fill them in order from lowest energy to highest energy. Pretty simple. The next rule is what we call the Pauli exclusion principle. And this we've done before too. It says each orbital can be occupied by only 2 electrons. We already know that, so that's not a big deal. So, and the other thing is that the 2 electrons in each position must spin in opposite directions of each other. Okay, so pretty simple. Each orbital can only hold 2 electrons, and they spin in opposite directions. All right. The next rule is Hund's rule, and Hund's rule states that no pairing of electrons occur in the P, D, or F sublevels and positions until each orbital of a given set has 1 electron. So each circle gets 1 electron or 1 slash or 1 arrow before you start doubling them up. Okay, Pretty simple there. So for example, if we're going to fill this in here, this one's going to get 1, this one's going to get 1, this one's going to get 1, and then we go back and start again. Okay, we put our next one would go here, and then here, and then here. Okay, pretty simple. So no circle gets 2 slashes before everyone has 1 slash. Remember, the slashes represent our electrons. Okay, so how to make these? First thing we're going to do, we said for our class, is use circles to represent the electron positions or the different orbitals. Okay, let's take hydrogen. If we look at our periodic table, pull that out now. Hydrogen, if you remember, its electron configuration is 1s1. So we're going to have, S only has 1 position, so we're going to draw a circle, and we find out from here that the S here has 1 electron, so we put 1 slash. Pretty simple. Let's do helium. Helium to the right of it, of hydrogen, and it's 1s2. Okay, so circle to represent the S, and then 1 slash to represent the first electron, 1 slash to represent this next one. Pretty simple with that. Okay, let's skip ahead a few. Let's do carbon. Remember, our electron configuration for carbon is 1s2, 2s2, and 2p2. So for the first one, we draw a circle, 1 circle for the S, 1 slash, 2 slash. Okay, we're filling the lowest energy first. Now we go up to 2s2. Okay, 1 slash for electron, 1 slash this. Now P, think, how many orbital positions are there for P? The answer is 3, so we have to draw 3 circles, and we fill them in. Remember, everybody gets 1 slash before anybody gets 2, so we get 1 here and 1 there. Now we still keep this third circle on even though it gets no slashes. Okay, so that's our electron configuration, notation and configuration for carbon. Let's try fluorine a little farther to the right on the periodic table. Okay, 1s2, 2s2, 2p5. Same way we started before. 1 circle for S, 2 slashes. 2s2, 1, 2 slashes. P, once again, 3 circles. Let's put them in one at a time. We get 1, 2, 3, 4, and 5. So everybody gets 1 before anybody gets pairing. So there is fluorine. So pretty simple. Once you guys have the electron configuration figured out, all you're doing is drawing circles under those to represent our last 2 quantum numbers, the magnetic and the spin. So let's take a look at where the quantum numbers actually are. So here's carbon. We just did this. Okay, first one we got the principal, right? Well, that's our number up front. Okay, in the example here's 2. We have a 2 there, here 2, 1 here. Our orbital, that's our position. That's represented by the letter. Okay, your magnetic is represented by the different circles. Okay, this would be a magnetic, this would be a magnetic, and here's the other one. And then finally, our spin is represented by the different slashes. So that we take both the electron configuration and the electron notation to give a full view, I guess, of where all 4 quantum numbers are located. Okay, so we will do more practice with this in class. So this section of this unit deals with writing electron configuration, telling what is the address of the electron and how to get there. If you're getting confused, please come see me. Remember, learn to read the periodic table. That way you don't have to memorize all those locations, the 1s2, 2s2, 2p, 3s2, and so on. Okay? Learn to read it, just like we read a book from left to right. S is the first 2 column, P is the far right, 6 ones, D's are in the middle, and F's are below. Once you learn to read the column, or read the periodic table, it's so much easier. Remember, D's are always 1 number behind, and F's are always 2 behind. If you are getting confused with this after you practice, don't wait to the test. Come in and see me. Alright guys, I will see you in class. Take care.